So today we are going to start a new topic, that is sequence and series. So what is sequence? What is sequence? It is a function. Sequence is a function. Whose domain is a set of natural number. Like example 1, 2, 3, 4, 5. This is in sequence also 1, 1 by 2, 1 by 3, 1 by 5, 1 by 7. This is also in sequence also 1, 3, 5, 7, 9. This is also in sequence. So two types of sequence are there, like in first of all finite sequence and infinite. What is finite? In case of finite sequence, finite number of terms are present. Finite number of terms are present. And in case of infinite sequence, infinite number of terms are present. Example of finite sequence is like 1, 3, 5, 7, 9, 39. This is an example of finite sequence. Finite number of terms are present. An example of infinite sequence, like this example you can give 1, 3, 5, 7. No nth term is not given, that is infinite sequence. So now what is series? We have studied sequence. Now what is series? Series in a sequence, the sum of directed terms. In this sequence, terms are given, the first term, second term, third term, fourth term. In this way terms are given. So what is series? Summation of all this term is called series. So in a sequence, the sum of directed terms is called a series. Example, for example, if 1, 4, 7, 10, 13, 16 is a sequence, then is a series. So this is the difference between sequence. Sequence is number of terms and series is summation of all those terms. Now we'll study progression. So what is progression? Progression is nothing but a sequence whose terms can be described as an explicit formula. Described as an explicit formula. Let me give you an example. Like in above I gave one sequence that was 1, 3, 5, 7, 9 ... This is an infinite sequence. Okay, So if we want to calculate t nth term of the sequence, we can easily calculate. That is, nth term can be written as, suppose first term 2n plus 1 or 2n minus 1. If you put n equal to 0, then nth term what will be? First term 1. But actually this is not true. Do you know why? I'll tell you. In the definition I have told you that sequence is set of natural number. Natural number, what does that mean? Natural number means n is not equal to 0. So here, for getting the first term, we have to put n equal to 0. That means n is not natural number, so we cannot put n equal to 0. That's why this will not accept it. And here if you put n equal to 1, then we will get first term, that is 2 into 1 minus 1, that is 1. Right? So nth term will be this one. Okay, understood why this will not accept it? Because n is natural number and n not equal to 0. So in this case we can describe this sequence as an explicit formula. So this is an progression. Okay, but if suppose it is given 1 3 9 13 17 19, this sequence we cannot describe in any formula, any explicit formula. That's why this is a sequence, but this is not an progression. Now we'll see. So progression, there are different type of progression. The different type of progression like AP. What does that mean? Arithmetic progression. Then GP, geometric progression. Harmonic progression, HP. Then AGP, that is arithmetic geometric progression. So in this video we'll basically discuss about arithmetic progression. So let's talk about arithmetic progression. What is arithmetic progression? And sequence in which the difference between any term and its previous term is constant, and sequence in which the difference between any term and its previous term is constant is known as arithmetic progression. AP. Suppose a sequence is given A1, A2, A3, an. Then difference between any term means, suppose difference between any term A2 minus A1, A2 minus A1 is constant. Suppose that this constant term is denoted by D, and this D is nothing but common difference, known as common difference. Also, if we take the difference between A3 minus A2, that is also D. In this way, an minus 1 is also D. So we can write down A2 minus A1 is equal to A3 minus A2 equal to an, A4 minus A3 is equal to an minus 1. Okay, so in order to find out whether any sequence is AP or not, one algorithm is given. If any sequence is given like A1, A2, A3, N, to find out whether this sequence is an AP or not, first of all first step we have to do, we have to find out the nth term, that is an. Okay, then what is the second step? Second step, replace n by n plus 1 to in n to get a n plus 1. What is the third step? Calculate a n plus 1 minus a n. Now if this, the result of this difference between n plus 1 minus n is independent of n, then it is AP. It is in AP. If it is not independent of n, then it is not in AP. For example, suppose it is given, suppose the nth term of an equation is given, example 1, n is equal to 5n plus 4. So what n we have got, and we have to find whether it is in AP or not. So first of all we have got n. What is the second step? It is first step. Second step, replace n by n plus 1, that is a n plus 1, that is 5 into n plus 1 plus 4, 5n plus 9. Now calculate a n plus 1 minus a n. Third step, a n plus 1 minus a n, that is 5n plus 9 minus 5n minus 4, that is 5. So this is independent of n, so this is in AP. Now another example, if we see, for example an is given to n square plus 1. Okay, we have to find out, we have to see whether this is in AP or not. So what is the second step? Replace n by n plus 1. Okay, 2n plus 1 whole square plus 1. So what we are getting? 2n square plus 4n plus 2 plus 1. Now what is the third step? A n plus 1 minus a n, that is 2n square plus 4n plus 3 minus 2n square minus 1. So what we are getting? 4n plus 2. So this is not independent of n, that means it is not in AP. It is not in AP. Okay, now one important point is that a sequence is not an AP if its nth term is not a linear expression in n. Let's see the example. It was a linear expression. Okay, nth term was given in a linear form, but it was not a linear expression. Similarly, if I take another example, like if n is given n square minus n plus 1, so similar way we can do, first of all we can get n plus 1, that will be n plus 1 the whole square minus n plus 1, that is n square plus 2n plus 1 minus n plus 1. Okay, n square plus n plus 2, right? So a n plus 1 minus n, what will be the value? N square plus n plus 2 minus n square plus n minus 1. right? N square will get cancelled out, so 2n plus 1, right? So n plus 1 minus n is 2n plus 1, which is not independent of n, as we are getting n here. So that means it is not an AP. It is not an AP. So if an expression is not linear, that will not satisfy the condition for becoming an AP. Okay. Now we'll see the general term of an AP. What? General term of an AP. Okay. If A is the first term, and D is the common difference, also L is the last term of an sequence, then AP can be written as A plus D, A plus 2D. In this way, L minus D, L, right? So how we can write this? Actually, we know that if common difference is A, D, then we can write like this: A2 minus A1 is equal to D, right? That means A2 is equal to A1 plus D. So if we add common difference with any term, then we will get the next term. In this case, we are adding the common difference with first term, then we are getting next term, that is A2. Similarly, if first term is A, if we add D with A, then we will get the second term. If we again add D, we will get third term. In this way, we are getting. Okay, so general term of an AP, that is denoted by AN or TN, whatever you want you can write, is equal to A plus N minus 1 D. This can be written in this way also, like Tn T1 equal to A plus 1 minus 1 D, that is A. T2 equal to A plus 2 minus 1 D, that is A plus D. So we are getting the same A plus D, T2. Similarly T3 will get A plus 2D. In this way we will get. So in this way we will get Tn is equal to A plus n minus 1 D. This is the general term of an AP. Okay. Now we'll solve some example. Suppose question is given, prove that log A, log AB, log AB square, this way dot dot, is an AP, and also hence find its nth term. Okay. So how can we do? We know for becoming an AP, the any term, any difference between the term and its previous term will constant. That means log AB minus log A will be equal to log AB square minus log AB. In this way it will go on. So let's see whether it is coming equal or not. So log AB minus log A, what we can write? Log AB by A. We can write this. That means log B. In this case we can write log ab square minus log ab, that is log ab square by log ab, right? That means that is nothing but log b. So the difference between two term is same, log b log b, so that means it is in ap. So what is the common difference? Common difference is log b. Now we have to prove, find its nth term. So we know the formula, that is Tn is equal to a plus n minus 1 into d. So here in this case a is log a, so write down log a plus n minus 1 into what is d? D is log b. So we can arrange this log a plus log b to the power n minus 1, that is nothing but log a plus log b, that is log ab, log a b to the power n minus 1. So this is the nth term. In this way, if any sequence is given and if it is in ap, then we can easily find out the nth term of that ap. Now we'll see sum of n term. Like n term is given, then what will be the summation of nth term of an ap? Sum of n terms of an ap. Okay. Again similarly, if a is the first term and d is the common difference and l last term, then we can write Sn equal to a plus summation a plus d plus a plus 2d plus l minus 2d plus l minus d plus l is last term. Okay, so if we write down this equation in reverse form, that is writing in reverse form, we'll get Sn is equal to l plus l minus d plus l minus 2d plus a plus 2d plus a minus d, a plus d plus a, right? I've just written it in reverse form, reverse direction. So if we add these two, then we'll get 2Sn, this and this I am adding, is equal to first term, that is a plus l plus a plus d, l minus d, that is a plus l. Here also a plus 2d, l minus 2d, that is also a plus l. In the same way, we'll get a plus l again and again, a plus l plus a plus l plus a plus l. So 2Sn equal to, we are getting a plus l up to n term. So this can be written 2Sn is equal to n into a plus l, or Sn is equal to n by 2 a plus l. This is the summation of n term. This can be modified. We know the l is nothing but, what is l? Here I am writing l is last term, that is nth term, n term. L is equal to Tn is equal to a plus n minus 1 into d. So this equation further can be written as Sn is equal to n by 2 a plus n minus 1 into d, that is n by 2 2a plus n minus 1 into d, that is this is the final expression of summation sum of n term of an AP. Thank you very much for watching my video.